Hello, data nerds and data enthusiasts. Welcome to my class. In this class, we'll be talking about data analysis. My aim is to help those who have interest in data analysis or learning basic programming skills using Python. So keep in touch, and also I urge you to follow me so you don't get to miss out on my videos. So before we go into coding properly, before I start releasing videos on coding properly, we'll have to look at the basic concepts of data analysis, because conceptual frameworks are very important in understanding a subject matter. So in doing that, I've been able to sectionalize the whole part of which we'll be following in this course. So you have nothing to worry about, absolutely nothing to worry about. So I have been able to divide the structure of the program into about 10 sections, like you can see, from section 1 to section 10: introduction, Python crash course, data manipulation, data cleaning, transforming futures, exploratory data analysis, and data visualization. Then on the subject matter, what is data analysis? Of course, we all have been hearing data analysis, but do we know what data analysis is? So now, simply, in a simple term, data analysis simply means collecting data and then providing insights and then interpreting the data. But then in the real world, or educationally, we can't just say data analysis as simple as that. So what is data analysis? So data analysis, from what I have here, I said data analysis is the process of systematically inspecting, cleaning, transforming, and modeling data to discover useful information, draw conclusions, and support decision making. Now, if you look at this definition very well, you will notice some terms. Now, the first term here says inspecting. So what are we inspecting? You are inspecting a data, probably getting the data from an external repository, or from a database, from a company's database, or from a data you yourself got primarily, maybe from individuals or organizations and all that. So what do? You get the data, you inspect the data. What are you inspecting the data for? You are inspecting the data, simply inspecting the data to see if the data is reliable, to see for errors like, let's say, duplicates. Maybe, let's say, for instance, you collect the data that involves students, you collect their name, and then you see that a particular name appears 2 times, 3 times. So you begin to ask, is this name for the same person or just different individuals answering same name? You try to look at errors, maybe probably why are there errors on some data, and then you look at some columns, you find out there are some missing values in the column. So why is this column empty? Why is this column have an ambiguous number? Like, maybe you don't, for instance, in a column that has to do with age, you are seeing 1000. So you begin to ask question, how is somebody's age 1000? So that is what inspection talks about. Then the next thing, you talk about cleaning. So after inspecting these errors and then seeing these errors, what do? You don't leave the data that way. You have to clean them. You have to do the correction, and then try to ensure data quality. The cleaning ensures data quality to make sure that whatever results you expect from that data should be accurate, and then should be useful to whatever field or area you want to use them. Then you talk about the transforming data. Transforming data can be in various form, but in order not to bore you with too many talks, transforming data is a simple term of, let's say, probably you can transform a data by simply creating new features that are not originally part of the data. Let's take, for instance, you collect data that involves age, weight, names of individuals, and then you want to calculate the body mass index of these individuals. But of course, you did not get the body mass index from them directly, but you can calculate it using their weight and their height. So that's, you're transforming the data. You are creating a new feature that was originally not part of the data. Then we talk about modeling. Modeling simply means building models for prediction. Then we talk about discover useful information. So having gone through this process, you get insights of which you can now interpret this data. So based on this data, this is what I have been able to find out. Now we'll say, who practices data analysis? Typically everyone practices data analysis: educators, engineers, scientists, researchers. Every sector, every part of our lives today depends on data. Data is like the driving force of the economy of today, because the advancement of technology has shown that we can literally not do anything without data, because doing anything without data these days is like planning to fail. So whatever sectors, whatever area or aspect of life you look at it, data is very, very important. So literally everyone performs or makes use of what? Data. So let's look at what are the key steps in data science. The key steps in data science, oh, okay, let me say, let's not say, I think I'll have to correct this. Let's say the key steps in data analysis. Yeah, the key steps in data analysis. Now, because we are limiting this particular course to just data analysis. Now, so we said the key steps: data collection, which I talked about, data cleaning, data transformation, that's structuring or reforming data for what? For analysis. Then exploratory analysis, modeling, interpretation, and communication. It is very, very straightforward and simple. So you collect the data, you inspect the data, you check for the need for transforming the data, and then it's just very, very straightforward, and it's not something that you can really go out of line for, because the steps are always very, very straightforward. Now you look at the types of data analysis. Okay, we look at the type of data, and the first one, now we talk about descriptive data analysis. Now let me give a very clear example that will make this very, very understandable and easy for you. So when we talk about descriptive data analysis, look at it as a form of you going to a hospital and then describing your symptoms to the doctor. You tell the doctor, I feel a headache, and then somehow my tummy pains me, and then I feel some pains at my back. So descriptive data analysis is looking at the data, describing a problem. So now when you look at diagnostic, after describing your problem to the doctor tries to carry out various tests on you to ascertain exactly what the problem is. So that is exactly what the diagnostic data analysis does. So you try to see the problem, the why, what is the issue, and then you look at the predictive data analysis. So after diagnosing the problem, you try to use the data to do what? To make prediction for future purposes. Okay, this is what this data currently is. So what can we see for tomorrow, for next year, for 1 year? So then after that, we look at prescriptive. Okay, we've seen the problem, we've predict what will happen tomorrow. What is the solution? What solution can we provide? That is prescriptive. You prescribe a solution to the problem. So those are the types of data analysis. So now let's look at data analysis versus data science. So now these two concepts have been used interchangeably, but in practice they are not the same. A lot of people see data science, data analysis, they feel it's the same, but no, they are not the same. In practice, data analysis and data science is not the same. Again, I use a very, very simple example that will make you understand it better. Look at data science as a faculty in a university, and then look at data analysis as a department. So data science is the broader form, or let's say the mother. It's a universal set, while data analysis is a subset. So in simple terms, data science involves multiple fields coming together, while data analysis is a branch of data science. So if you see what I wrote here, I said data science is an interdisciplinary field combining statistics, computer science, and domain expertise to extract knowledge and build predictive or prescriptive models, building systems and models that learns from data and make decisions or predictions. So data science is in the broader form. Data science, a data scientist is both a data engineer, a data analyst, and a machine learning engineer. So which means he's capable of mining data, engineering data, and carrying out various transformation, analyzing data, and also building predictive models. While a data analyst is simply just focused on cleaning data and then communicating the insight or the information from the data. So you see, data science is under, and data analysis is under data science, while data science is the mother of data analysis. So now let's look at a comparison table between data analysis and data science. Now the scope of data analysis is very, very narrow. Ask specific questions, no complex questions, while on the part of data science is very, very broad, end to end, solving complex problems. You define a problem, try to build models to solve the problem, and then go on and on. Then the techniques used in data science are basically just statistics and visualization. You calculate mean, median, mode, you understand basic statistics, and then you visualize this data in form of probably, let's say, graph, tables, diagrams. And then when we talk about the techniques in data science, it involves machine learning, building models. It could be building models using various algorithms, XGBoost. You employ high degree level of statistical tools, and then use of AI, big data, complex data of, like, let's say 1,000 rows, 500 rows, 1 million rows. So it's very, very complex. It's a broader form and a broader term of as compared to data analysis. Then say the goal is to understand past and present. Why for that of data science, the end goal is predict the future, prescribe actions, that's prescribed solutions. Then when we look at the tools, basically Excel, SQL, R or Python. Then when we look at data science, the tools mostly use the Python and machine learning libraries, Spark and cloud machine learning. So the output are basically reports and dashboard, which is well known. So why for data science we talk about predictive models and automated systems such that from the models you've been able to build, they can be included into systems such that when data are fed into the system automatically detects patterns and then give result and output, so we don't have to repeat the process again. So but then in this course we are concerned about data analysis, because I myself, even as a data scientist, my major interest is in machine learning, but I kind of have love for data analysis as well. So let's look at the data science process, just like we talked about the data analysis process. The data science process, like I said, data science is the mother of data analysis. So which means data analysis is a subset of data science. So like you can see, like I outlined here, this data science involves data engineers, data analysts, machine learning engineers, gives you what? Data scientist. So when you combine these roles together, that is who a data scientist is. So that is why I said you look at data scientists as a faculty and then data analysis as a department under the faculty. So let's look at the process. We said problem definition. You define a problem. A company, a hotel contacts you and tells you, we want to conduct a marketing optimization campaign. This is the resources we have and we do not know how to go about what to focus on. So you define the problem. For instance, predicting average revenue using so resources, or using so modeling. So you define the problem, and then what do? You start collecting data. So the data the company has or the hotel has, you start gathering them, doing a lot of cleaning, inspecting. Maybe probably not enough, you have to maybe depend on external expositories and then repositories rather, and then try to compare. So it involves a very huge process. And then you talk about data cleaning and preparation, the EDA, the feature engineering, getting new features outside that, maybe segmenting the customers into clusters and then classifying the customers, the hotel guards. So it involves a lot of process, and then you build models, the model evaluation, you see how good the model perform, and then if the model perform well according to the benchmark that have been set, you deploy the model into the system, and then you monitor, you keep monitoring the performance of the model, and then carry out maintenance. From there, communication as an insight as well. So then having said all of this, so what then is data? So if I can remember back then in the days during introductory computer science in the secondary schools, and even in the early days in the university during bachelor's, we've been told that data is a processed information, while information is a collection of data. I don't know if I'm right, but I know that's how they know. Say data is a processed information. Yeah, that is true, because of course data, when you collect data for an information to become data, definitely you must have seen a pattern and understand it. So now when we look at this, I said a collection of objects with different attributes and features to describe an object. So when you meet an individual, for instance, you ask them, what is your name? He said, my name is John. I'm from Edo State, or I'm a Nigerian. I am 1.22 feet tall, and this is my weight. So that is data you have collected from such individual. So now I can put that in a report. I can say John is a very tall guy, now without actually specifying the actual height of John, and his weight is not too fat and he's also not too slim. So I'm passing an information of John to another person without necessarily seeing John. So the person does not actually have to see John for him to know the information about John. So that is what data is. So it's simply just collecting features to describe an object. The car is red, the car has four tires, and then the plate number is green. So those are information. It describes the object. You collect features and attributes to describe an object. So that is what data is. So what are the types of data? Of course, just like we have data, we have types of data. Data can either be categorical or numerical, but it doesn't just end at that. A categorical data can also be subdivided into various forms. Like you see here, a categorical data can either be nominal or ordinal. When a data is nominal, is a categorical data and nominal, it simply means the data cannot be ranked. For instance, if I say red, blue, white, green, red, blue, white, green, and yellow, and I ask you to order it, how can you order it? You cannot say green have to be first. On what condition or what characteristics are you using for green to be at the top, then followed by red? No, you cannot order it. So that is a categorical nominal data. Then when we look at ordinal data are categorical data that can be ordered. You can rank them. For instance, if I say hot, cold, warm, of course you can rank them, right? Maybe based on the temperature, you can rank them. Then if you look at the other one, we said numerical data. Numerical data can either be discrete or continuous. For instance, when I say age can be discrete. So you are either 12 years or so. Or probably sometimes some data can both be discrete and continuous. So then when you look at it, some data can be discrete and they can be continuous. For instance, temperature is continuous data. You can have 0, you can have -1, -1.2, you can have -3, like that. So these basic concepts are things you understand before we start going into coding properly. So now let's look at characteristics of big data. We've talked about data. Data these days are always big, especially for big firms. You see data that contains a lot of rows and a lot of columns. So what are the characteristics of big data? We call them the 5 V's. Number 1 is the velocity. Number 2 is the volume. Number 3 is the variety, and then veracity, and then value. Now the velocity simply means how quick the data comes. Is it in real time? Is it being saved in a database and then later accessed? For instance, data gotten from bank are real time. As the customers are depositing the money, the system is recording them immediately. As you are withdrawing the money, the system is recording them immediately. So they are real-time data. So the velocity simply talks about the speed at which the data are being gotten, while the volume talks about the size of the data. Is it in kilobytes? Is it in bytes? Is it in megabytes? Is it in terabytes? So you understand, that is the volume. While the variety is talking about the different forms of the data. Is it in graphical form? Is it in table form? Is it in the HTML form, CLV, the varieties, the different formats of the data. While the veracity is talking of how accurate, how reliable the data is. Then the value, how useful is the data you are collecting? Is it useful? Do we actually need it? So that is what that is talking about. So for us to go into using Python, you need a computer system, and also you need internet, and then you need time. So first of all, if you're using Mac like me, it might be quite straightforward. If you're using Windows, it can be quite straightforward and easy as well. So you have about 3 options for which you can install Python on your computer. Number 1 you can decide to install VS Code. Number 2, you can decide to install Jupyter Notebook. Number 3, you decide to use Google Colab, which is an online version of an online IDE of Python, where you don't have to download the app. It's just go on Google and just type Google Colab. So just create an account you can use. Then if you want to have a VS Code, I use VS Code, so I recommend VS Code as well. So it's simple for Mac users. Most times Python is installed. What you have to do is just probably install the IDE. So maybe just go on Google and type okay, let's see, you just go on Google and then you type, let's say, download VS Code. So if you enter here, so you can see for Windows, for Mac. But then before downloading the environment, you need to have first of all install Python on your system. So to install Python, you can just go to python.org, and then okay, downloads. When you click this, so you see for Windows and you see for Mac. So you first of all install this before installing the environment. So if you after installing Python on your system, but I think for Mac, Python are mostly pre-installed in, yeah, but probably you can just, maybe it might be an old version, so maybe probably just install the new version, which is the Python base 3.14, which I just 3.14. so after installing this, you come and install VS Code. If you don't like VS Code, you can download Jupyter Notebook as well, or probably if you don't want to go through the stress of installing that, just use Google Colab. It's an online version. So you see, I already have an account. You can see my picture here already. So in our next class, I'll show you how to use this environment, and then we'll start immediately.